2009, number 2. The rate at which people enter an auditorium for a rock concert is modeled by the function r, given by this rate. Again, this is a rate. And this is measured in people per hour. No one's in the auditorium at time 0 when the doors open. The doors close and the concert begins at time 2, 2 hours later. How many people are in the auditorium when the concert begins? Well, we've got a rate. We want to know how much stuff. Right? So, actually, let's just call it the r of t function. That'll be a little easier. This is a number 2, calculator again. So let's see, we want to do math 9 fn int of 1380 x squared minus 675 x cubed comma x comma 0 comma 2. That'll give us how many people came in from 0 to 2. 980 people. Right? Integral over rate gives us the amount of stuff, the amount of change. Now, if there had been 20 people in there to start with, this would be the amount of change, so it would add the 980 to that. But they said there's no people there, so it's actually 980. Okay? Find the time when the rate at which people enter the auditorium is a maximum. Justify your answer. Well, they want to know when the rate is at a maximum. This is the rate. So let's graph it and find the maximum. So 1380 x squared minus 675 x cubed. Looking from 0 to 2. And what kind of numbers are we thinking about here? The rate that they're coming in at, maybe like 500. Actually, that might not be enough. Maybe let's try 1,000. Certainly could be more than 1,000 because 980 people came in the whole 2 hours. So that should be enough. Whoa, just barely. So there's the maximum. So find the time when that rate's at a maximum. So I can calculate maximum happens at time 1.363. Maximum of r of t is equal to, it happens at time 1.363 hours. And this is, I don't know what they want us to do here. I'll say maximum from graph of r of t. Maybe that's enough. Who knows? Okay, part C. The total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. All right? So the function w models the total wait time for all the people who enter the auditorium before time t. The derivative of w is given by w prime of 2 is equal to 2 minus t times r of t. Find w2 minus w1, the total wait time for those who enter the auditorium after time t equals 1. Well, if we have this and we want to know w2 minus w1, that should remind you of like fundamental theorem. The integral of w prime of t from 1 to 2 would be equal to the antiderivative of this, which is the w function at 2 minus w at 1. So I think we just need to evaluate this, right? And we have that. right here. So I need to do math 9 fn int of 2 minus x times the r of t function, which is 380. I think I have it in y1. I could have done that too. X squared minus 675 x cubed. I think that looks good, right? Comma x, comma 1, comma 2. 387.5 hours. That's total wait time. All right, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time from Part C. Well, if you want the average wait time, that's the average value of the wait function, right? Of the waiting function. So we want the average value, that's 1 over the 2 hours, 0 to 2, of the W function, right? And, well, hold on a second. Let's think about this. Let's scratch that for a minute. We just found here, this is the total amount of wait time for those who entered the auditorium after time 1. So let's redo that calculation from 0 to 2. That would give us, by the same logic here in this part, that would give us the total wait time for those who entered the auditorium from the beginning. So that would be the total wait time, right? And we know the total number of people who came in. So if we can find the total wait time and divide by the total number of people, then I think that we have found the wait time per person. So on average, how long a person would wait. I think that's what we need to do here. So total wait time from t equals 0. So let's go back and just redo that calculation, but do it from 0 to 2. So now, sorry, I can't see that in my, there, 760 hours, and there's 980 people. So 760 divided by 980 gives us 0.776 hours per person. So I don't know if you thought the same thing that I did there. It looked like average value at the start, but actually not average value, because the wait time function, we don't actually have access to the W function. We can get this information because we had the derivative. So I think that's the way to go with that one.